All right, so some more protractors. If y'all were listening the other day, this tool right here is a protractor. And what do I know about a protractor? What does it measure? Doesn't measure temperature. This is not 120 degrees outside. They measure angles. All right, so we're going to do a quick review of drawing on a protractor. I will tell you something I do not like about these protractors, and I would almost ask the kids if they can tell me what's different about these protractors than the ones that they've seen on the other assignments. Problem is, this one just goes 0 through 180, and real protractors, and the ones they'll see on STAR test, they have 0 through 80 going both ways. And this is from Text Guide, so that kind of bothers me a little bit that they don't have the correct protractor. I digress. All right, so girls, read us the first one. Boys, you should be following along. And if they say RAD, remember, say angle. All right, so look down here, class. I want y'all to read what it says underneath the protractor together because you're building that fluency. All right, so we need to say whether we agree or disagree with the student. Explain. All right, well, first of all, what student are we talking about? Oh, this one up here. What did the student say? The student concluded that angle RAD, angle R-E-D, is 120 degrees. So I'm going to start here with something. What could y'all tell me without the protractor, and I'd cover that up, what can you tell me about a 120 degree angle? Hopefully, if your kids have been making connections and you've been helping them make these connections, they're going to tell you, well, that's an obtuse angle. Well, how do y'all know it's obtuse? Oh, because it's more than 90 degrees. Let's write that. And yes, we need to write it, read it, write it, say it. 1 time is never enough. 2 times is not enough. You might remember it today. You might even remember it 3 days from now. But if you want to have it next year, it's because we read it, write it, and say it like 50 times. It's not just saying it. So I know that 120 degree angles are obtuse because obtuse angles are more than 90 degrees. We ought to look at the angle. Let's highlight RAD. Angle R, here's the R, so R to A to D. This is the angle. I'm not even going to look at the numbers on the protractor. Do you agree that RAD is a 120 degree angle? No, me either. So that's no, I do not agree, I disagree. Explain it. Well, one reason I would say is because angle RAD is yes, it's an acute angle because here, see your loser right there? Your capital L, loser. This is less than a loser. It's an acute angle. And how much does it measure? Well, which point is 0? Point R, point A, or point D? None of them because they've screwed up and they didn't put a 0 on both ends. So here's what we're going to do. We're going to pretend this is 0. And how many degrees do we know these jump from number to number? 10. So I want y'all to jump and let's count by 10s. Are y'all ready? 10, 20. Y'all should be jumping. 30. I should hear y'all. 40, 50, 60. This is a 60 degree jump. Now, some of your really mathematical kids might have told you to do 180 minus 120 to find the, look at this keyword, difference between. I would not probably, you could mention that, but this would be what most kids understand. All right, so we're going to explain it. So, do you agree with RAD? No, comma. I disagree, and let's do our best on our spelling because it's labeled right there. No, I disagree. What should we say? Because what? What's it? Is it a fluffy cloud? Is it a rock? Because angle RAD, R-A-D, is an acute. Now, I'd ask y'all before they keep going, why did I write an instead of a? They should know that and comes before vowels. If a word starts with A, E, I, O, or U, we say an. No, I disagree because angle rad is an acute angle. You could put a period. I would ask them to elaborate. What else could I add? What do I know about this acute angle? 60 degrees. So no, I disagree because angle rad is an acute angle measuring 60 degrees, period. Get up and go walk around as they're, I know I write faster than y'all, I always tell them that, but you should be following behind, writing neatly. If you see them writing messy, say, nope, I want you to erase, do that again. Or, hey, you misspelled this word. You don't have to say it in front of everyone, but just kind of, I always would go like, hey, you misspelled because, look at the board, that kind of thing. Now, obviously, if your student's dyslexic or maybe they can't see well, that's a little different. So, just kind of gauge what you know. All right. Girls, read us the next one. All right, class, read underneath. And then once again, we're either agreeing or disagreeing with the student, and we're explaining. All right, it's back to this kid up here. What does this kid say? This kid says angle rad is 150 degrees. What do I know about a 150-degree angle? It's obtuse. Why is it obtuse? Because it's more than 90 degrees. All right, I'm going to write obtuse, but we already have up here that it's more than 90 degrees. Where's the angle? Let's highlight it, okay? So let's find angle rad. Angle R to A to D. So this is rad right there, that angle. Would you say that this is an obtuse angle? I agree. Can any of you tell me, and I would ask the kids this, I'm going to try and stump y'all. Why do you think some kids might say that this is obtuse, especially if they know obtuse means more than 90 degrees? Why do you think they'd still say this is obtuse? Hopefully, in a minute after some thinking, look, this ray, the sunlight, this ray of light comes across 150 degrees. And this ray of sunlight comes across 90 degrees right there. How do I know that's 90? Because it's between 80 and 100. So just because the segments are going through those numbers doesn't mean that this is a 150-degree angle or a 90-degree angle, because the angle is right here. It's the space between. So another reason I know it's not obtuse is because if I built a loser, if I built a capital L off of one of these segments, see how I'm building a capital L? This is less, which makes it a cute little angle. So my question is, what if they asked you to find the degrees of this? Which point is on 0? Point R, point A, or point D? Which one's on 0 degrees? None of them. So this is like a starting line. This is like a race. These racers are starting right here. So this is going to be their 0, their starting point. And they have to get here to finish. So we're going to start from here. This is our 0. And when we go digit to digit, what do we know we're counting by? 10. All right. Y'all get that first arc. Let's count. That's 10. Keep going. 20, 30, 40, 50, 60. It's another 60 degrees. Only difference is this one was at a 0, even though sadly they have a bad protractor. This wasn't Miss Pierce's fault. 0 to 60. This is 62. They try to trick you by not starting on a 0. So how do I know that I disagree? Here's Miss Pierce's. See above. Yep, this is the way Miss Pierce likes to roll. It's math, it's not writing class. See above, teacher? I disagree because it's acute. It measures 60. Truth. Oh, I already answered this. I wouldn't have told him what I did. what else is different besides the angles being different measures of degrees, which, no, they're both 60 degrees, so you might fix that. So even though both of them are at 60 degrees, what is different? And the difference is this one was at a 0. This one is not at a 0. That's all I really would want them to come across. All right, let's do some practice. All right, so finding missing angle measures. All right, let's read this all together. I am missing a whole amount or a partial amount. Well, we're trying to find this x. Is this the whole model or part of the model? I agree, that's a part. So what do we know about parts? They're small. Well, if you're trying to get small in math, what are your two options? Subtract, as in take away, or divide, as in split it up. Well, if y'all were paying attention the other day, with angles, all we're doing is either adding or subtracting. So therefore, because I need a part, we're going to subtract. Subtract. All right? So, subtract from what? If I'm missing a part, where's my whole amount? And remember, if they're stuck, remind them. Remember, the whole model is from one edge to the other. So if you're going from one side to the other, this would be the whole amount. So what's your whole model? How do y'all know it's 90 degrees? Some might say, well, it's because it's a loser. Losers are right angles. Or some kids might go, hey, Miss Pierce, it's that square. Remember that square? He's like, dude, I'm a loser. I'm sitting in a loser. I'm 90 degrees. So 90 minus 62 will give me that small part. So whole minus part equals part. So we're going to line it up vertically. 90 is larger, putting it on top. Whole minus part equals part. If you have 0, can you pull 2 out? No, so we take a 10 and regroup it into how many? 10. 10 minus 2. 8. 8 minus 6. 2. So our missing angle is 28 degrees. This is reasonable. What does it mean it's reasonable? It makes sense. Why does 28 degrees make sense for this angle? Because it's small, get better than that. Ah, okay. Because it is an acute angle. That's why it makes sense. All right, look at the next one. We're trying to find A right here. This is what we're missing right here. Is this the whole picture or is it a part of the picture? All right, so if we're looking for a part, we need to get small. That's right, so we need to subtract. Well, if you're missing a part, what's the whole amount? The whole amount would be from one edge to the other, from one side to the other. What type of angle is this? It's a straight angle. What do we know about straight angles? They measure 180 degrees. And that's because if you were watching the other day, here we go. You've got these two segments or these two rays. And then all of a sudden, you start opening the door. And so, which would be a lot easier with that one hand because this guy wouldn't be moving. So, when you open up on a straight angle, how many degrees is this right here? 90. How do we know? Because losers, right? And then what's on this side though? Another right angle. How many degrees? 90. Yeah, and as you close it, you've got an open 180 degree angle. I wish I could figure out, let's see. I don't know if y'all can see this. So it would look like this. Opening, 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 90, another 90, straight angle. I don't know if that worked. You might have seen nothing. Or you might have seen the sleeping pug. Pixie Pug. Say hi, Pixie Pug. Say I'm napping. Oh, look at the tongue. It's out. That's happiness right there, Pixie Pug. Can you say hi? She's like, don't bother me. All right, back to this. So the whole angle is 180 degrees. I would go ahead and get the kids to do something like this, where it's 90 plus 90. They seem to really remember straight angles when you kind of build in 90 plus 90. All right, so 180 whole minus part equals part. Whole minus part equals part. So we're going to line up 180 degrees, and we're going to subtract 134 degrees. Genius right here. If you have 0, can you pull 4 out? No, so we're going to take away a 10. Now, for those of you who've never really watched this, and sometimes I draw this for my kids, a rod, what you've done is you had 8 rods. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7. Here's my 8. And you take 1 away. So now you have 7. And this one gets broken down into 10 singles. So that's what we mean when we're regrouping. 10 minus 4 is 6. 7 minus 3, well, you have 7. You take out 3, you're left with 4. 1 minus 1 is 0. So we were missing a 46-degree angle. Is this reasonable? Is this number 1 that makes sense for this angle? Yes, because it is an acute angle. We say "and" because the word acute starts with a vowel. All right, on this one, let's see what this reads. Angle ABD represents the blank. Let's highlight it. Angle A to B to D. Is that the whole or a part? It's the whole thing because you're going from one side to the other. So this is the whole model. W-H-O-L-E, not a hole in the ground, right? To get, I don't know why I have an angle there. To get a whole amount, we will need to get big. How are we going to get big? We're going to add. You could repeatedly add, which is multiply, right? Except that with angles, we're not doing that. All right, well, that makes sense because part plus part makes whole. Part plus part, whole. Vertical, though, we don't try to add in our head like that, not with numbers that aren't friendly. 9 plus 2 is 10, 11. And we regroup. Here's what I would do. 1 and 2 makes 3, and now we have doubles, 6. So we have a 61-degree angle. What type of angle is that? Acute. Yep. All right, this next one. Angle A right here. Angle A represents a blank angle. Oh, I see now. Now I need to pay a little more attention. Angle A I'm looking at what I'm trying to figure out here. Angle A represents, yeah, I had it right the first time. See, I'm second guessing myself in front of y'all. I'm sorry. Is it really 9:35? Angle A right here. Angle A represents an acute angle. That's a cute little angle right there. And that's because here's your loser, and this is less. And that means acute measures less than 90 degrees. The whole angle is blank. Well, the whole angle is where you go from one side to the other. So if you go from this side to this side, what type of angle is this? No, what type? It's a straight angle that measures 180 degrees. So the whole angle amount is 180 degrees and is a STRAIGHT angle. So what does angle A measure? Well, this is 180 degrees, but here's what I know. What's on this side? 90. What's right here? 90. So whole 90 minus part equals part. 90 minus 51 is part. So that one's kind of tricky. I guess you could do 180 minus 90 minus 51. I mean, there's no wrong way to do this. I just like to work the smart way. What I would ask the kids, does this make sense? Yes, it's reasonable because it's an acute angle. All right, last one. Angle VXW. V to X to W is a blank angle. What type of angle are we looking at here? Yes, I agree. This is obtuse. O is a vowel. A-E-I-O-U, so we'd say an. Measuring, what do we know about obtuse angles? More than 90 degrees, yep. Angle YXW, Y to X to W. What type of angle is that? Straight, S-T-R-A-I-G-H-T. S is not a vowel, so we would just say a straight angle, and we just have said like 3 times 180 degrees. And we're looking for VXW. VXW. So from here to here. So, are you looking for part of the amount or all of this amount? All, because you're looking from here to here. Part plus part makes whole. Part plus part makes whole. 129 degrees. The end.